In section 6.6, we'll now be solving logarithmic and exponential equations. We'll use the properties we found in section 6.5 to solve these equations, and we're going to be using the definition. So let's review the definition of the log that says the logarithmic function to the base a, where a is greater than 0, a is not equal to 1, denoted this way. Y is the log to the base a of x, is defined by y equals the log to the base a of x if and only if a to the y is equal to x. Y is the exponent, a is the base. The domain of the logarithmic function is 0 to positive infinity, or in other words, x is greater than 0 is another way to say that. And here's a summary of the properties we saw last time. Recall there were 9 properties, and then the 10th thing was the change of base formula. So this is just a summary of those here for your use. So our strategy for solving logarithmic equations algebraically will be to rewrite the equation using the properties of logs, so it's written in one of 2 ways. It depends on the particular equation on which you would do. You'll either write it to look like the definition, it's just with the y on the other side of the equal sign, but that's basically our definition, or we'll write it as log base a of something equals log base a of something else, or log equals log is what I tend to call that. This is what I call the definition. This is log equals log, because then we can use the if log base a of m equals log base a of n, then m must equal n. So if it's in the form of the definition, then we change it to an exponential and solve for x. If it's in the form of log base a of m equals log base a of n, then that's property number 9, and we'll just say that m equals n and solve from there. It's always a good idea to check your solutions and remembering the domain x greater than 0. Okay, so let's try following this strategy and solve some logarithmic equations. So example 1, we have a log equals 2 times log. So if we, to solve this, we can use the idea of what? Which one of those? We can use the definition or the log equals log, right? Well, in this case, we can use log equals log, but it's not log equals log yet. It's log equals 2 times the log, right? So what can I do with that 2? If I divide both sides by 2, then I'll have a 2 in the denominator on this side. Well, there's a property that says, hey, that 2 can become a power. So let's rewrite this as log base 3 of 4 equals log base 3 of x squared. Now I have it in the form of log base a of something equals log base a of something else, right? M and n. So we can use that property number 9 and say, well, if that's true, then this is true. And then take the square root, whoops, of course I'm getting ahead of myself here. Take the square root plus or minus, and I get x equals plus or minus 2. But now I have to check to see if both of these are in my domain. Go back to the original. If I plug in positive 2, that's fine. But can I plug in negative 2? No, because x has to be greater than 0. So in my curly brackets, the only solution I can put is 2. The negative 2 is not in the domain for this particular function. Okay, so this was one we could do as the log equals log. Let's look at the next one. We have log of something plus log of something equals 1. It's a sum. They have the same base. I can combine that into a single log. I can write this as log base 2 of m times n, x plus 2 times 1 minus x. Now, because I have log base a of x equals y, I can change it to an exponential, right? The base 2 to the 1 equals x plus 2 times 1 minus x. So now just solve this quadratic, right? 2 equals, first times first is x, outside times outside, negative x squared, inside times inside 2, outside times outside, negative 2x. Okay, so that's 2 equals, what do I have? Negative, I'm going to put my descending powers on the variable, so I have negative x squared, I have a positive x and a negative 2x, so negative 1x plus 2. I'm going to subtract 2 to get it in quadratic form, negative x squared minus x, and now I can just factor out a negative x, leaving behind x plus 1. Let's check that. Negative x times x, negative x squared, negative x times 1, negative x. So negative x equals 0 and x plus 1 equals 0. So x equals 0 and x equals negative 1. Now, are both of these in my domain? Let's go back. If we put 0 here, this is 2. Remember, my argument here has to be greater than 1, so putting 0 in there, or greater than 0, that's fine. Putting 0 in here, that's fine. That'd be log base 2 of 1. So 0 seems fine. Can I put the negative 1 in? Negative 1 plus 2 would be 1. That's still greater than 0. 1 minus negative 1 would be 1 plus 1, or 2. So that one also is in the domain. So my two solutions are 0 and negative 1. So you have to go back. You either establish your domain at first and determine what the domain of this function is, or at the end you go back and plug them in and make sure that your argument is greater than 0. Either way, but you have to check the domain, as you saw here. We did have to exclude one of the answers. Okay, let's look at example 2. Solve this equation leaving it in exact form. Okay, I have natural log plus natural log equals something natural log, right? So I can combine these two. It's sum, so it'll be a product. And I'm just going to put the x in front of the x minus 1 to show that. And that's the natural log of x plus 2. And so now I have log equals log. That's number 9. If the log base a of m equals the log base a of n, then m must equal n. So then x times x minus 1 must equal x plus 2. That has to be true. So this is x squared minus x equals x plus 2. Let's subtract x. X squared minus 2x equals 2. Subtract 2. X squared minus 2x minus 2 equals 0. Okay, that's not factorable. So let's go to the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So x equals 2 plus or minus the square root. Negative 2 squared is 4, and negative 4 times negative 2 is 8. So I have the square root of, what, 4 plus 8? Or 12, all over 2. And I'll just write it again up here before we simplify. Okay, the square root of 12 will simplify, right? Take out the factor of square root of 4 and times the square root of 3. Square root of 4 is 2. So this x equals, I can take factor out of 2 out of the numerator. And now I can cancel common factors, so I get x equals 1 plus or minus the square root of 3. Now I have to leave in exact form, so I'm not going to find out what the square root of 3 is and round it. That's what I've got. But the question is, that's two answers, right? Is 1 plus the square root of 3 in my, back up here in my domain, and is 1 minus the square root of 3 in my domain? Okay? So I might need to find out what those are equal to just to have an idea, you know, a rounded inexact answer, just to know where they are on the number line. So this would be 2.732, and 1 minus the square root of 3 would be negative 0.732. And I did that just so I can get an idea when I come up here. And of course the negative one gets thrown out immediately because the natural log of negative is not allowed. So that one's gone. Now, 2.732. So that would be fine here. natural log of 2.732. Certainly here, because that would be 2 plus that, which is fine. And if I take 2.7 and subtract 1, I still have a number that's greater than 0. So it looks like I get to keep that one. So my exact answer is 1 plus the square root of 3.